Alright, welcome to a special Halloween episode. I don't really have a costume. I guess I'm going to be an overly ambitious network engineer. Sounds scary to me, especially if I'm signing up for tests like the JNCIE-SP. I think I've got the scariest costume on of them all. So in addition to that, we're gonna crank up the scares to 11 by doing a rare late night episode beginning at 10:30. Much later than I usually have them. Okay, so last video we learned about classification for QoS. So this video we'll be moving on to a new topic. Okay, so the new topic is going to be scheduling, and I'll bring my tablet up. I have it charged to the max now, I think, unless it had, nope, it's charged to the max, perfect. And we'll start a sketchpad so we can continue thinking about QoS as if it were a grocery store and customers coming in and out, buying groceries, checking out, getting special perks for having special memberships, that sort of thing. So let's pull up the sketchpad. Okay, and then we'll go to the URL that my tablet has. Okay, so now we've got the ability to sketch. We're probably going to need that later, so let me just make sure we're good to go. Alright, and we're good, so won't need that for now, but it's there if I need it. Okay, so we're moving on to scheduling. I'm almost tempted to just jump straight to Google the way Help Apropos has been letting me down lately, but I do want to take full advantage of that. Anything on exam day that I can look up and not have to worry if I've got right or wrong is going to be a huge advantage for me. Okay, so right now, yep, so this is going to be scheduling instead of classification. Okay, and let's take care of the tags. All right, so yep, and we just had one video for the last one. I just don't think classification is a super complicated topic, and not only that, Help Apropos did have instructions for setting up each of those kinds of classifiers. Now, BA yeah. So let's take one final look at the configuration here. Or sorry, at Help Apropos, just to affirm that I have built-in help for that. And I hope this doesn't turn into another unplanned video like I had before, where I had planned to move on, but I ended up doing another round of multicast practice. Huh, I've never seen this before. Oh, I see. Okay, so we've got class of service. Here we go, examples for an MF filter. Let's see if we've got one for a BA filter. Let's do type match MF dash and BA dash. We do. Okay. So, yep. Everything I think looks there. I remember from the last video. So let's move on for real. We're going to do a help apropos search for scheduling. Okay. So, yep. Let's start with this, and then we'll do these. So I'll put both of these in my notes. Okay, so this is differences between per unit scheduling and shared scheduling. Shared scheduling allows you to allocate separate pools of shared resources to subsets of logical interfaces belonging to the same physical port. Per unit scheduling enables one set of output queues for each logical interface configured under the physical interface. An unconfigured logical interface in the context of CoS is a logical interface that you configure at the edit interfaces, interface name, unit, logical unit number, hierarchy level, but do not configure at the edit class of service, interfaces, interface name, unit, logical unit number, hierarchy level. The differences between per unit scheduling and shared scheduling are as follows. With per unit scheduling, an unconfigured logical interface receives its own set of output queues. With shared scheduling, an unconfigured logical interface receives its own set of output queues only if there is some configuration for that logical interface at the edit class of service, interfaces, interface name, unit, logical unit number, hierarchy level. When you configure shared scheduling, include the shared instance statement with the traffic control profile. The shared instance statement is not supported with per unit scheduling. When you configure shared scheduling, a dedicated scheduler is assigned to a logical interface on the output direction only. If you configure one or more of the following, a scheduler map, a shaping rate, a guaranteed rate, or a traffic control profile, all the other logical interfaces use the same set of queues in the output direction. Similarly, a dedicated scheduler is assigned to a logical interface on the input direction only. If you configure one or more of the following, an input scheduler map, an input shaping rate, or an input traffic control profile, all other logical interfaces use the same set of queues in the input direction. Okay, so let's read the other one. Okay, so not only does this not seem to be related to CoS, this is for M6160 routers only. I'm not sure what kind of routers we have on the test, but this is this is not going to be a M160. This is going to be a right here, model VMX. So this is not an M160. And I'm not sure what's going to be on the exam. They'll either be VMXs just like this, or they'll be probably MX80s. But one thing I know for sure, they're going to be MX routers, and not M routers. Okay, so let's read through the class of service overview. The CoS configuration available for the ASPIC enables you to configure differentiated services, the diffserv, code point, DSCP marking, and forwarding class assignment for packets transiting the ASPIC. You can configure the CoS service alongside the stateful firewall and NAT services using a similar rule structure. The component structures are described in detail in the Junos class of service configuration guide. Standards for differentiated services are described in the following documents. CoS BA classification is not supported on services interfaces. For more information about configuring CoS services, okay, so I'm kind of, the first one I read seemed okay, but I think it's time to switch over to Google. Definitely a good idea to get a good sense of what's in help apropos, because that's what I get on the test if I get stuck. Got to be sure to use it and to use trace options as well. Absolutely going to be essential. Okay, yeah, so class of service is the correct thing to match if I want to see relevant stuff. Yeah, so I'm just wondering if there's one more thing that would be good to read. Here we go. So examples, scheduler. So are we working on scheduling? Yes, we're working on scheduling. So I did a match for scheduling, but I did not do a match for scheduler. So I missed this documentation here. So this is configuring rate limits on IQ2 and enhanced IQ2 PICs. You can rate limit strict high and high queues on IQ2 and IQ2E PICs. Without this limiting, traffic in higher priority queues can block the transmission of lower priority packets. Unless limited, higher priority traffic is always sent before lower priority traffic, causing the lower priority queues to starve, which in turn leads to timeouts and unnecessary resending of packets. In the IQ2 and IQ2E PICs, you can rate limit queues before the packets are queued for output. All packets exceeding the configured rate limit are dropped, so care is required when establishing this limit. For more information about configuring CoS on IQ2E PICs, see CoS for enhanced IQ2 PICs overview. To rate limit queues, include the transmit rate statement with the rate limit option at the edit class of service scheduler name hierarchy level. You can issue the following operational mode commands to verify your configuration. The first one shows the rate limit in effect. Okay, so that looks good to me. Let's do a match on scheduler. So we can do this and then match scheduler. Here we go. So we've got all sorts of stuff for scheduler. So I think this input scheduler map is going to be key. We've got priority schedulers, hierarchical scheduler, and input scheduler. Got all sorts of different kinds of schedulers. Alright, that one doesn't look so good. Let's try scheduler maps. Hierarchical scheduler. Okay, so this section provides a more complete example of building a 4-level hierarchy of schedulers. The configuration parameters are shown in building a scheduler hierarchy. The queues are shown at the top of the figure with the other 3 levels of the hierarchy below. Let's take a look at the queues here in this GIF. Okay. The figure's PIR values are configured as the shaping rates, and the CIRs are configured as the guaranteed rate on the Ethernet interface. The PIR can be oversubscribed, that is, the sum of the children PIRs can exceed the parents, as in SVLAN 1, where 200 plus 200 plus 100 exceeds the parent rate of 400. However, the sum of the children node levels CIRs must never exceed the parent node's CIR, as shown in all the service VLANs. Otherwise, the guaranteed rate could never be provided in all cases. This configuration example presents all the details of the CoS configuration for the interface, including the interface sets, the interfaces, traffic control profiles, schedulers, drop profiles, scheduler maps, and applying the traffic control profiles. Okay, so that's going to be it. Okay, we've got terminology. So hierarchical schedulers. Oh, and my arm and neck is kind of being weird right now. So, like really weird right now. So I think I'm gonna like lay down or something. Oh, bear with me, please. I think. What is this? Oh, it's a French fry. Okay, so I'm gonna just like lay down a little bit because my neck is like doing something. But okay, so hierarchical schedulers introduce some. Thought I had like a pillow or something, but whatever. This is gonna be fine. Introduce some new terms into a discussion of CoS capabilities. They also use some familiar terms. Different contexts. This section represents a complete overview of the terms used with hierarchical schedulers. The following terms are important for hierarchical schedulers, and there's a lot of them. First term that's important is customer VLAN, CVLAN. A CVLAN defined by IEEE 802.1ad. And I'm gonna get a pillow here so I can okay, because I need to lay down. My neck is doing something. Okay. Okay, so the first term that's important is customer VLAN, CVLAN. A CVLAN defined by IEEE 802.1ad. A stacked VLAN contains an outer tag corresponding to the SVLAN and an inner tag corresponding to the CVLAN. Oh, there we go. A CVLAN often corresponds to CPE. Scheduling and shaping is often used in a CVLAN to establish minimum and maximum bandwidth limits for a customer. See also SVLAN. Next term is interface set, a logical group of interfaces that describe the characteristics of set of service VLANs. Logical interfaces or customer VLANs. The interface sets establish the set and name the traffic control profiles. See also service VLAN. The next important term, and what we're learning about in this topic, is scheduler. A scheduler defines the scheduling and queuing characteristics of a queue. Transmit rate, scheduler priority, and buffer size can be specified. In addition, a drop profile may be referenced to describe WRED congestion control aspects of the queue. See also scheduler map. Scheduler map. A scheduler map is referenced by traffic control profiles to define queues. The scheduler map establishes the queues that comprise a scheduler node and associates a forwarding class with a scheduler. See also scheduler. Stacked VLAN, an encapsulation on an S VLAN with an outer VLAN corresponding to the S VLAN and an inner VLAN, inner tag corresponding to the C VLAN. See also service VLAN and customer VLAN. Service VLAN, S VLAN, and S VLAN defined by IEEE 802.1 AD often corresponds to a network aggregation device such as a DSLAM. Scheduling and shaping is often established for an SVLAN to provide CoS for downstream devices with little buffering and simple schedulers. See also customer VLAN, which was the first term that was important. Here we go. Got some manual massage tools here. So the next important term is going to be traffic control profile. And this defines the characteristics of a scheduler node. Traffic control profiles are used at several levels of the CLI, including the physical interface, interface set, and logical interface levels. Scheduling and queuing characteristics can be defined for the scheduler node using the shaping rate, guaranteed rate, and delay buffer rate statements. Queues over these scheduler nodes are defined by referencing a scheduler map. See also scheduler and scheduler map. And the final important term, one that we already know, all the way back in the first day of networking you would have been exposed to. Probably not the first day actually, you probably just learn about a regular LAN first. Is VLAN, a virtual LAN, defined on an Ethernet logical interface. So yeah, you definitely wouldn't learn about VLANs on day one. You'd learn about them pretty darn quick, or at least begin to, but it can be more of a advanced topic. Well, not advanced, but it's definitely advanced beginning topic, that's for sure. So you definitely wouldn't learn about it on day one. You'd learn about just a regular LAN first. These terms are especially important when applied to a scheduler hierarchy. Scheduler hierarchies are composed of nodes and queues. Queues terminate the CLI hierarchy. Nodes can be either root nodes, leaf nodes, or internal non-leaf nodes. Internal nodes are nodes that have other nodes as children in the hierarchy. For example, if an interface set statement is configured with a logical interface, such as unit 0 and statement and queue, then the interface set is an internal node at level 2 of the hierarchy. However, if there are no traffic control profiles configured on logical interfaces, then the interface is set at level 3 of the hierarchy. Hierarchical scheduler nodes shows how the configuration of an interface set or logical interface affects the terminology of hierarchical scheduling nodes. Table 45, hierarchy scheduling nodes. So, okay. Schedule hierarchies consist of levels, starting with level 1 at the physical port. This chapter establishes a 4-level scheduler hierarchy, level which, when fully configured, consists of the physical interface level 1, the interface set level 2, one or more logical interfaces level 3, and one or more queues level 4. Okay, so I'm back. Yeah, my neck and shoulder feels pretty good. I took a pretty long walk, so it kind of shocked my body a bit, but I'm feeling decent. Oh my god. Okay, so yeah, that was a pretty good documentation, I think. I'm kind of walking away from it pretty confused, but that's not always a bad thing. So that was the terminology. Let's take a look at the application next. Oh my god. Oh, here we go. So hierarchical schedulers and traffic control profiles. When used, the interface set level of the hierarchy falls between the physical interface level, level 1, and the logical interface, level 3. Queues are always level 4 of the hierarchy. Hierarchical schedulers add CoS parameters to the new interface set level of the configuration. They use traffic control profiles to set values for parameters such as shaping rate, the peak information rate, PIR, guaranteed rate, the committed information rate, CIR, on these interfaces, scheduler maps assigning queues and resources to traffic, and so on. The following CoS configuration places the following parameters in traffic control profiles at various levels. Traffic control profile at the port level, TCP port level 1, a shaping rate, PIR, of 100 megabits per second, a delay buffer rate of 100 megabits per second, traffic control profile at the interface set level, TCP interface level 2, a shaping rate, PIR, of 60 megabits per second, a guaranteed rate, CIR, of 40 megabits per second, traffic control profile at the logical interface level, TCP unit level 3, a shaping rate, PIR, of 50 megabits per second, a guaranteed rate, CIR, of 30 megabits per second, a scheduler map called smap1 to hold various scheduler queue properties, level 4, a delay buffer rate of 40 megabits per second. For more information on traffic control profiles, see oversubscribing interface bandwidth and providing a guaranteed minimum rate. For more information on scheduler profiles, see configuring scheduler maps. In this case, the traffic control profiles look like this. Okay. Once configured, the traffic control profiles must be applied to the proper places in the CoS interfaces hierarchy. In all cases, the properties for level 4 of the hierarchical schedulers are determined by the scheduler map. Okay, so we're hitting the half an hour mark of this video pretty quick. Let's actually, for realsies, move over to the Juniper QoS scheduler examples online. So here we go. Configuring class of service schedulers on a security device. Okay, so that one looks good. Let's see if there's a better one. So I guess I'm not sure which one I want, because this one looks pretty good. Oh, but this one is for QFX and EX routers. Those aren't the kind of routers I'm doing. And in fact, those are our switches, not routers, so that's not going to be a good one. Okay, so here's the overview. So let's read the overview. Okay, that's for switches again. So we're going to add both of these to the notes. Okay, and then we're going to read the full overview, and then we're going to do the example, and that will be the end of the video. I think I'm going to need to take a break before I do that, so I'll pause the video. I'll be back shortly.